told that our original volume equals to 10. What we are told to calculate is what? Change in volume. They said increase in volume. So it means that our V1 is what? 100 meter cube. So if we are given these parameters and we already have our gamma to be what? 12.3 times 10 to the power minus 6 per Kelvin. What do? You just input all these values into there. So you have 12.3 times 10 to the power minus 6 equals, this is what we are looking for, change in volume all over our normal volume, which is 100. Do you understand? Then times change in temperature. 50 minus 0 will give you also 50. So by the time you what calculate this, you have V2 minus V1 will equals to what? 12.3 times 10 to the power minus 6 times 50. So our V1 minus V2 minus V1 will give us what? 12.3 times 10 to the power 6, then times 10 to the power 2. I have to break this down using what? Indices. So from there times what? Let's say extract 0 here, put 5. So this comes 3, 5. You understand? So from there you have 12.3 10 exponential 6, 10 exponential 3, then 5. So from there you have 12.3 times, if you put this together, you have minus 3. That's minus 6 plus 3. So you have minus 3. So you bring down your minus 3, then times 5. So 5 times this will give us 5, 1, 10, 1, 1, 5, and 6. 61.5 times 10 to the power minus 3 per Kelvin. So that, with that, we have gotten our change in volume. So that is the actual value. We're going to another exciting topic today, which speaks about electric charges and structure of matter. Electric charges and structure of matter. Here we'll be looking at what charges, what do you actually mean by electric charges, and also the structure of matter. When you say electric charges or charge, electric charge, and what we also talked about, and when we also talk about structure of matter. Now, these two particular phenomena are somehow related, are somehow interrelated as regards the way charges move, and all charges have a kind of structure of matter. Now, before we proceed, I'd like us to actually bring back our idea to what we call electrical field. Electrical field. Now, if you recall, the last time we spoke, I broke something down as regards the actual meaning of field. And we said a field in sciences or a field in engineering actually meant a particular region where, if peradventure it is electrical field, let's say electrical field for instance, electrical field is any field where electric charges are actually what? Experienced. The performance or the movement of electric charges, the particular region where they are being experienced are called electric field. Now, if you also bring it down to magnetic field, the magnetic field, if you recall the other time we drew diagrams of magnets as regards magnets with the north and south pole, when you have two magnets related to each other. Now, I'm actually emphasizing on this because you have to understand what field actually means for you to actually now go into electrical charges. So I hope this is actually clear as regards the meaning of what electrical field. So we will now proceed by looking at what electric charge actually means. Now, static electric is defined, or static electric current, let's put it this way. A charge, when I talk about electric charge, a charge will also be called a current. So when we say static electricity is defined as electric charge at rest, what do I mean? When you have your charges, this is a negatively charged electron. We call it what? A negatively charged electron. Now, when you have this particular charge, now what does it actually mean? It's been stated as a static. It's been stated as an electric charge that is what? At rest. Now, when it comes to what electric charge, we are not looking at its movement now. Maybe through a conducting material, for instance, a metallic object. Electron can move via this metallic object or via a metallic wire. Now, whatever this is, this is another field entirely. But right now we're looking at those charges at rest. Now, their activities when it comes to when two or more bodies come in contact with each other. Now, let's take for instance a plastic cone rubbed with a cloth with many with someone's hair standing at the end. Now, if you look at it, what are the experiences that actually what are the things that are actually experienced? Now, if we talk about the human hair, if you bring closer a comb attached to it. Now, when you comb the hair or when you actually use this comb to rub this hair, a time will come that this comb will become what? Electrically charged. Electrically charged. You understand? Now, when this comb is charged, by the time you move it closer to any other insulating object, let's say a paper, do you understand? A normal paper, which is what? An insulator. If you move it closer, you will discover that this paper will stick to this what? This comb, meaning that this comb has been charged just because it was being moved closer to human hair. Another example is the interaction. I mean, if a rod is charged by rubbing them with 4, what does that statement mean? It means that when you rub your rod with a 4, now from the diagram there you understand what I meant by a 4. You rub your the rod, a normal rod, you rub it closer to what is called a 4. A 4 is just like an insulator or an insulating material. Do you understand? If you rub your rod closer to that 4, you discover that this particular rod will get charged while it's being rubbed with this 4. Now, if you read if you read continuously with that statement, you realize that the rods repel each other. But if a glass rod is rubbed with silk, the glass rod becomes charged and repels each other. What does that mean? It means that we're looking at two particular objects. We are looking at rod, 4 and rod. We're also looking at what? Glass rod. Now, this particular rod is metallic, mind you. It's a metallic rod. Now, there's a glass rod. If you like, rub a glass rod with a silk. So we are looking at two occurrences now. One is metallic rod and 4. Now, the second one is what? Glass rod and what? And silk. So when these two objects are actually brought, as in two bi-objects are actually brought closer to each other, a 4 and a metallic rod, now a glass rod and a silk, there is what? There is experience of what? Electric charges with each other. So let's proceed. Now, if we now go further, I hope we understand what is actually being experienced there. Let's go back to the statement for you to actually really get it. Now, the interaction between electric charge at rest can be observed by considering one, you have a plastic rod and a 4. Oh, sorry, I beg your pardon. This is not metallic. This is supposed to be a plastic rod. You know, we said there are two types of rod. There is plastic rod and there is glass rod. Now, we want to look at the experience of charges between a 4 and a plastic rod, then the glass rod and a what? And a silk. Now, with the explanation there, we're told that at rest and can be observed during, considering the what? Plastic rod and what? A piece of rod. A piece of 4, sorry. Now, if the rods are charged by rubbing them with 4, the rods repel each other. Now, what does that mean? Your plastic rod, if it's being rubbed with your 4, now, this rod will become charged. Now, if you place this rod closer to another rod, they repel each other. Now, this same occurrence happens to when you move your glass rod to your silk. You rub this glass rod on this silk. This glass rod becomes charged. Now, when it's being moved closer to another glass rod, any other insulating object, they will repel each other. So that is just the analysis as regards how some objects are being charged. Now, in this case now, if probably is your plastic rod, now it's being moved closer to your 4. Now, if your plastic rod probably does not have a charge, let's put it this way, your 4 is being charged. So by the time it's being rubbed, you now have a resultant occurrence of your what? Of your plastic rod being what? Positively charged. Meaning that the charges in your 4, little have been transferred to your what? Plastic rod. So also, that same experience is being what? Discovered here. Movement of charges or objects being charged while, due to what? Coming closer or bringing closer of what? 2 or more. That is a plastic rod with your 4, then your glass rod with your silk. So let's proceed now as we move further. Now, another thing we need to look at is the structure, the actual structure of atom. When we say structure of atom, we need to understand what we are talking about here. When we say charge, you understand? Let me put it this way: electrical charge. Now, your charge could be negative. You understand? An atom could be, let me put it this way, an atom could be negatively charged. Now, a negatively charged atom or ion, let me put it, an ion could be negatively charged. Now, a negatively charged ion is called what? Electron. Now, a positively charged ion is called what? Your proton. Proton. Then the neutral. There is a particular one that is what? Neutral charged. Neutral charge. Now, the one that is actually neutrally charged is called what? Your neutron. So we have three major classes of what? Your what? Charge. Now, your charge could be what? Negatively charged. Now, your ion could be positively charged or what? Neutrally charged. So if you look at it very well from the statement, we say scientifically, atoms is the smallest indivisible particle which undergoes a chemical reaction at a particular period of time. What do I mean? That statement actually talks about the real definition of what? Atom. If you buy some definition from, you recall, from the definition in chemistry, what is an atom? An atom is the smallest indivisible particle, meaning that if you take a stone or a piece of stone or whatever, now no matter how minute it is, by the time you keep dividing, the point where you see, the point where you get to, these are fractals, these are